Boom! What's up, everyone? Welcome to Simulation. I'm your host, Alan Sakyan. Very excited to be talking about the robot explosion. We have Andra Keay joining us on the show. Hello.
Hi, it's such a pleasure to be here again.
Yes.
So much is changing so quickly in robotics. It feels like it's been a lifetime since we last talked.
I know. Thanks for joining us for round two.
Okay.
Yes, and so, like you just said, so much has changed. It was a year ago that we talked. It was around May, and you guys can find the link to that episode below. And since then, it's just, like you said, so much has changed. We're going to be unpacking that in detail. For those that don't know, and Andra's links are below as well. She's the managing director of Silicon Valley Robotics, last 8 years doing that. She's also the founder of Robot Launch Global Startup Competition. We'll be talking about that a little bit as well. We love starting off with this big history perspective on civilization. Here we are at this interesting AI robotics automation moment in history. What is your current take on the state of humanity?
Well, when I just look at the state of robotics, I'm really optimistic. When I look at the state of humanity in general, I think today the doomsday clock is actually going back to 2 minutes ahead of midnight, which is the, that's pretty severe sort of summary of what the state of humanity is. But I do like to be surrounded by people that take the long view or the deep view of what our problems are, and look at solutions that are going to be really able to make changes. And that's what draws me towards robotics, because I think it's the technology that is going to be most useful at making positive change in the world. I know some people get scared of it, but I really think it's the answer to a lot of the grand challenges that we're facing at the moment, whether that's the aging population, the food supply, just trying to find security in our food supply and to double the amount of food that this planet is producing in this next generation. So the demand is increasing all the time, but we have run out of ability to produce food. Our production kind of metric has stayed really static for the last 30, 40 years, and the amount of land that can be turned into farmland, we've really reached the limits of that. And not only have we reached the limits, but we're reducing that land through both natural disasters that could be related to climate or through urbanization. The majority of the world's population is moving into cities and moving away from farming. How do we fix that? How do we make an abundance of food for everybody on this planet? How do we turn that into something where people don't have to fight over access to food or other natural resources? And I think that means improving productivity across the board, not simply in agriculture, but productivity in every area. Robotics as a technology allows us to build much smarter technologies that ideally can do things like manufacture in place, which is a lot of what the Industry 4.0 ideal is, to have local manufacturing everywhere and really reduce the amount of moving that things have to do, which consumes a heck of a lot of energy and other resources.
So robotics being able to tackle all of the world's biggest issues is something that you really see as
definitely.
A major part of this. You said, aging is one of them, agriculture as another one of them, our insane amount of use of resources.
Energy, and indeed maintaining all of our resources. On the one hand, for example, forestry and mining are the two most dangerous jobs on the planet. So we can look at it one way, which is just, can we make those jobs safer by using autonomous trucks, autonomous digging machines, or robots to help survey tunnels or go out to oil rig areas. So on the one hand, you can look simply at, can we save lives that we're currently in danger using our resources the way that we do? And then secondly, how can they also assist us in developing new, more effective and more efficient ways of harvesting energy or converting energy?
Okay, I'm very excited to continue unpacking this as we keep going. So you've been doing speaking, advising, investing, just synthesizing the robotics kind of state of what we have, and then also teaching that to other people. Now, so what's been happening then in the history of robotics?
Yeah, well, one of the things that first introduced me to how robotics has changed in the last 20, 30 years was the way that DARPA instituted grand challenges using robotics. And the one that most people are familiar with is the Autonomous Vehicle Challenge, and that was all the way back in 2004, 2005, and 2007. You know, it seems like a really long time ago, but DARPA has a really good history of looking at something that is 20 to 30 years out in terms of the technology, our ability, our timeline for achieving that technology, and bringing it at least 10 or 20 years closer so that it starts to become of interest commercially. And since the DARPA Autonomous Vehicle Challenge,
let's pull up Stanley now. So that's our next image. So
Stanley,
yes,
Stanford, they were the first car to win one of the DARPA Autonomous Vehicle Challenges. Because I will add, in the very first race, nobody won. Nobody crossed the finish line, nobody came close. But within 1 year, the technologies had improved so significantly that there were, I think, more than 32 entries, and Stanford won, much to the chagrin of Carnegie Mellon, because they had been used to being the #1 contender. But at this time, the autonomous driving efforts were largely within research. It was the CARS facility at Stanford, and it was Carnegie Mellon. And what happened straight after that is that Google started acquiring self-driving technologies out of the universities. And that started people realizing that this might not be 20 years off, that some people were starting to bet, or even unattainable, some people were starting to bet on this coming in the next 20 years. And since then, we've had a lot of people go public with predictions that we'll have fully autonomous vehicles from about 2015 onwards. We haven't gotten there yet, not at all. But we have had self-driving vehicles on the 101 in the Bay Area, and now in many, many other places since 2011. Right now, there are more than 50 companies licensed in California to be testing self-driving vehicles.
50 companies licensed
and
to test.
And we go back to 2005 and look at all of the sensors and lidars that are up on the top there. Those are at least twice as expensive as the brand new four-wheel drive vehicle that they're sitting on. Mm-hmm. So one of the things that's changed since then, if you think about it, 2005, that's pre-smartphone. Mm-hmm. So since then, the smartphone has really contributed significantly to the revolution in affordable component technologies that are also useful for robots, aka self-driving cars. So smaller chips, better connectivity, and smaller, cheaper sensors. So those things together, better computation, ubiquitous connectivity, and affordable sensors, has really been at the heart of what, in fact, Gil Pratt, who ran the DARPA Robotics Challenge at that time, he called it a Cambrian explosion in robotics. Mm-hmm. And that's why, for me, I'm living in the middle of that. That resonates so much, because what I can see is not just a quantitative explosion in the number of robots, robot companies, and the funding of robot companies, but there's also a qualitative change. And if you're not really up on your prehistory, the Cambrian explosion is the biological period, which is just a sliver of our whole biological timeline. But within that period, we went from having very, very simple organisms that could move, that came in a few different shapes and sizes, to having representatives of every single variation of life on this earth, just within that period. And what is theorized that led to that is the development of vision systems, the development of eyes. Mm-hmm. And as organisms developed eyes, they created so many new ways of growing and using them. It became a case of, were you going to hunt other organisms down, or were you going to avoid them? How did you grow to better meet the new niches that were emerging in the ecosystem? So we had this explosion of variety, not just of quantity, that happened in the Cambrian explosion. And that is exactly what we're seeing in robotics. An explosion in the quality, the variety of sorts of robots that are out there. And it's happened because we hit this tipping point in terms of the building blocks of technology. We can now build robots that have better sensing abilities.
Yes.
And that allows them to do a lot more.
There were a couple things that you said
Yeah.
that are really important there. One of the things that you said was that it's fascinating thinking about how grand challenges contribute to cutting edge innovation from teams around the world. So the more that we can incentivize grand challenges at the scales of $1 million in prizes, you know, like similar to like what X Prize does and what, you know,
Yeah.
Jun Yoon has been doing with his prizes, that we do think that that's a major driver for innovation. Another one that you mentioned was the fact that these sensors on top of Stanley used to cost so much money and now have dropped in cost by
Orders of magnitude.
Significant.
And the range of sensors available is just continuing to increase.
And the range of sensing is now increasing. So this is kind of the next point, is that, you know, we see these curves, you know, with Moore's law. We see these curves with the Carlson curve for genomics, for sequencing DNA as well. That all of these curves that are making it more and more inexpensive to do the computations that we so desire are causing this exponential technology age. And then this last thing that you mentioned I thought was super interesting was that when you compared the Cambrian explosion in biology to the robotic explosion that we're going through right now, or this exponential technology explosion, you also made it clear that it was because in biological systems due to the perception. So there was perception, and then the new algorithmic sequences that these biological organisms are able to then take and see, is it avoiding prey, is it going and finding new prey, is it making new shelters, all that kind of stuff. Similar with robots now, with perception with robots, with autonomous vehicles, with drone technology, with dexterity, with all these different things is leading us into this explosion. So then now, what is then robotics 1.0 versus 2.0?
That is a great question. That I look at this, and this is an example of robotics 1.0, but supremely sophisticated, working on human beings, but highly controlled, very, very expensive systems. We've had surgical robots since SRI was developing the, say, the Taurus gripping system, which was commercialized by Intuitive Surgical. And this is what I call the big end of robotics. We've had in robotics 1.0 pretty much two varieties of robots. One is the factory industrial robot arm, and they're also very expensive. They're also very dangerous, and they remain locked away in cages in factories, in no-go areas. You don't have people working with those robots at all. And this one might even become a collaborative robot arm because that's quite recent, but pretty much most of what robotics has been for the last 50 years has been a version of this robot arm, or a very, very $1 million variant, which is the surgical robot, which, as said, just in terms of it's highly controlled, very expensive.
They have a lot of degrees of mobility here, so they can, you know, you spin around on the very bottom, you angle this arm, you extend it out. What is it? How many degrees of freedom is it? Is it specific?
Well, that one maybe only has 3.
3 or so, but now the cutting
4
edge is,
if you count the end. But
now the cutting edge is what, like 7 or something, 8?
Well, I think we've had robotics 1.0 7-axis mills. If you think about it, just a CNC machine. Subtractive manufacturing, 7 degrees of freedom. You can do highly complex geometries. You can mill metals like titanium. You can construct parts for the aerospace industry, or you can perform surgery. These are great, but they, like I said, they don't have the ability to work beyond their own. You can't reprogram on the fly, and you can't get in the way of their work envelope. So these are machines that lack perception. These are machines that are effectively simply executing code or being teleoperated directly by the operator. These machines do not think for themselves. Indeed, if you look at the definition of robotics, which says a machine that senses, thinks, and then acts, you would have to say that almost every Robot 1.0 company isn't really a robot anymore, because they sense and they execute code or execute joystick commands, as it were, to take action. They're not making decisions. They're not really being driven by perception in the loop. Robotics 2.0 companies look like those robot arms, but they're able to navigate around people because they will have different mechanisms that allow them to sense people. They'll also be able to be mobile. That's the big change. Self-driving cars, but also mobile robots inside of supermarkets or delivery carts or vehicles, or mobile robots within warehouses or on farms or in mines. So this is navigating in its environment safely around people. So it's using perception to navigate. And that's where I'd go back to saying, even the robot arm that we were showing before isn't really a Robotics 1.0 arm, because it's got a perception system there, at least of some kind. And quite often you'll find that there is touch sensing, capacitive sensing, force sensing, or there are cameras inside of a work envelope. So there are a range of ways that robots now can sense if somebody's interfering with work and take the appropriate action, or they can respond. So you can retrain a robot and you can say, pick up this like this. And someone doesn't need to really call in a very expensive integrator or rewrite code. You can push a button and retrain a robot system. So this is the essence of Robotics 2.0. It is qualitatively different. The robots are employing perception, and this gives them the ability to navigate in the real world. And while we might not have fully self-driving cars on the road yet, we now have autonomous robots in our supermarkets. We now have delivery robots in parts of the world, whether it's a warehouse or a suburb in Arizona. So we're seeing robots coming out of the factory and out of research into the real world, and we're starting to see the numbers climb. Robotics 1.0, industrial robots, there are fewer than 2 million of them in the world. Now, 2 million might sound like a lot of figures, but back in 2011, 2012, Foxconn's chief said, I'm going to put 1 million robots into my factories by the end of 2014, which the newspapers all ate. They gobbled that up, but everyone in robotics went, there are only at that point in time 1.5 million industrial robots in the world. Where are you going to get? You know, how are you going to double the number of robots in production? The world's capacity for building robot arms suitable for use in factories is already max capacity. You can increase by X percentage. You are not going to get 1 million robots in a 3-year time frame. He did not. He has kept that vision alive though, and he's increased Foxconn's robot production, and the number of new producers of robots has increased. So we're now at 2 million industrial robots. We're expanding the range of categories of what robots are, and the number of companies building robots has quadrupled. And of course, within those changes, a lot of those companies have shifted. So some of the European and American companies that were building robots have been acquired by Japan and China.
And Japan's the number one.
Yeah, Japan is the number one producer of robots in the world today, and China is the number one consumer of robots in the world today. And those changes have really just come about in the last couple of years. Europe, Germany in particular, they have the highest concentration of robots in use per capita of society. And in general terms, the US is around about 5th place across all of those statistics.
Yeah, when you're explaining the difference between 1.0 and 2.0, I think it's so awesome that robotic perception and then being able to then process that stimuli, and even if you need to dynamically make code deployments or to just make it so that it can relearn on the fly is so fascinating, and then make decisions as well. And like you were explaining here, now you have instances where robots, like instead of being behind enclosed areas where you can't operate by humans, with the perception systems that we have with the 2.0 era, they can engage around humans and potentially stop if there's a human coming by, etc.
Absolutely. All of these robots, and this is what I call Robotics 2.0, they're mobile, they're capable of taking the right sort of avoidance behaviors around people and to make some sorts of predictions as to how people are going to move. And clearly if you look just within a supermarket aisle, you're going to find many different types of movement. You're going to find a store associate, for example. They might spend quite a lot of time at any one spot in the store and not move easily. They might have boxes beside them. You will find people that have trolleys and strollers and moving up and down, and you will find that children will have a very different movement pattern to adults who are shopping. And just to be able to make a reasonably accurate assumption as to whether or not somebody is going to need to intersect with your path and how to deal with that. We've been working in the field of human-robot interaction for a very long time on scenarios like this, and it's so exciting to see those scenarios turn into real-world issues. And there are at least a half dozen companies with large deployments at major retailers like Walmart, Target, Kroger, Amazon, Alibaba. In fact, there's probably more than 12 companies doing just inventory robotics alone. And within the retail umbrella, there are probably 5 or 6 different deployments of robotics technology that are getting put into trial right now. And that ranges from, say, robotic shopping carts to the frictionless checkout.
Yeah, correct. Which we have right here. Standard Cognition's located right here, right in this exact same building. It's crazy. So, and what else is nuts when we're looking at this? Not only like you're explaining, is it mobile? I think what else is nuts is that there's 2 perception systems happening simultaneously. Yes. There's the one that's actually scanning inventory and processing that, and then uploading that data for the retailer to know where to go and send people to go stock, and soon send robots to go stock. And then 2, the other perception system that's crazy is the one where it actually has to go and make sure that the humans that are walking up and down the aisles, the ones that are stocking, the kids that are probably trying to come and play and touch the robot, that they're avoiding that. And then it's really cool that you said that there's a dozen, and I just want to over the different sort of robotics companies that are retail robotic inventory companies. I wanted to make clear, like I saw a post, I believe it was Andra Keay was reposting about how there is a significant amount of jobs, inventory management jobs that are disappearing because of this. I also find it interesting to at least ask the question, well, how many hundreds, if not thousands of people are now working as engineers, designers, ops people, marketers of these new companies as well? So what are your thoughts on the amount of jobs that are potentially lost but also gained? Where do you
think assuming that jobs are being lost because of this is really premature. Firstly, because every robot deployment that I know of tends to need to have a caretaker, a robot wrangler. Robots are still really stupid, and what we want is them to behave perfectly around people. What we need is to have someone to go and find it when it's gotten boxed in a corner because someone put out a tray of something and it can't get out. What we need is people to just look after the robots constantly. So working in robotics has a really big skill range. I find robotics companies all the time looking for people just to help manage deployments, to physically babysit robots. So we're going to need robots babysat, first off. It's not necessarily a high-skilled job. Second off, when you look deeply into the actual task that's being taken, these robots are running constantly. How often was inventory being done in that store previously? And it's more likely to be a handheld inventory scan on a weekly basis, an empty shelf scan on a daily basis, and then a large stock take once a year. So when you find out how rarely something is happening, you realize this is the characteristic of a commercially successful robotics deployment, is it's not taking a job, because if a person is doing that job all the time, people are still really flexible and really good at the jobs that they do. But if it's something that is really hard for people to do, so we can only fully inventory a store once a year, well, we're finding out that a job like that tends to have very inaccurate results when compared to a robot survey of the same inventory.
More inventory data points over time, which is extremely
Not just
important.
over time, but the comparison that most of the major retailers have found between their annual stock takes and the robots report, the quality of the robot inventory taking is twice as good as their human inventory taking. And this was the best inventory taking that they could get.
Wow, yeah.
So it's like right now, humans are definitely better at dynamic management of situations, whether that's, you know, pinpoint stock reshelving or customer service or adapting to all of the different jobs within a supermarket.
Yes.
But robots are really good at doing those monotonous kind of tasks. And in fact, one of the hallmarks of Robotics 1.0 has been what people call the 3Ds, and that's dull, dirty, dangerous. And I say it's actually the 4Ds because these are the dumb robots. The dumb robots that can't really navigate successfully. Robotics 2.0, robots like these, I say it's the 4 S's. They're smarter, they're sensor-based, they're capable of social interaction, even if it's non-verbal interaction. So they may be capable of a dialogue, but they're also capable of navigating around people, understanding that this is a shared space. So they have to have social ability, even just a little bit. But the limitation of them, where the 4Ds of Robotics 1.0 means that effectively they're dumb, the limitation for Robotics 2.0 is simple. Single task, simple robot. Smarter, sensor-based, social, yes. But each of these robots is doing one thing. They are not taking inventory and stocking the shelves. They are not providing navigation around the store. They're doing one task and they're focusing on getting that task right. And a lot of robot companies in the early days of developing retail robots made the mistake of trying to put everything on board the robot to see what was going to stick. So they had the ability to scan parts, the ability to teleoperate, telepresence, bring in an associate from somewhere to ask questions, the ability to provide navigation and guidance. You know, everything was being tested out. It was a very experimental stage. And ultimately, a robot that can do most things 60% well is just not necessary. What we need to keep focusing on is doing one task out of the whole range that a human in the store can do, but doing that one task at a really successful level. So what I say, it's the 4 S's: smarter, sensor-based, social, simple, really simple.
And then when you get really good at doing the simple task, and you're with the Robotics 2.0, you can combine the simple tasks once you've gotten really, really good at those into potentially single dexterous Boston Dynamics style robots that are running around the store.
Possibly. Although I think, you know, it's going to be an interesting case and we'll see people taking different directions. There might be one store that chooses to have the robot do both inventory and shelf stocking. But I think it quite likely that we'll continue to have a robot doing inventory and then a completely differently designed robot doing shelf stocking.
Interesting, Okay, now you're doing a lot more writing as well right now, which is very good, and it's on kind of like the current state. We've been talking about that a little bit and where it's going into all of the different industries. And then you were mentioning, social robotics, which you're very interested in right now. So teach us about that.
Well, my background area was human-robot interaction, but also the sociology of robotics. Which is really understanding what robots do we end up with in society, why do we have those robots, how do we interact with those robots at a broad level, whereas I find human-robot interaction tends to focus on the psychological. And while it's fascinating, I think that how things operate in the wild and at large is often very, very differently to what we've seen in small interactions. So I'm very interested in robot interactions in the wild and at scale. So part of my work has been with Silicon Valley Robotics doing commercialization for emerging robotics companies. And another part is just looking at what is happening in terms of where robotics is going. Are robots going to be good for us? Are they going to be bad for us? How do we navigate that? And how do we provide people with the best possible information about that as well? So we don't really need to know about the uncanny valley. That's something people love talking about. They love talking about Asimov's laws for robots. But I can tell you right now that you cannot code ethics or morality into a robot. Just is not going to happen.
This was interesting when you were talking about this with me a little bit ago. I wanted to know more about, you know, we're still struggling on the human ethics and morals level, so it's very difficult to figure out how to possibly do that on a robotic level. But on a governance level and on a lawmaking level, in order to ban, you know, killer robots, that type of stuff, that is something that we can do.
Oh, absolutely. And I think part of the realization that there are things that we can do is about realizing that it's human society and we have certain frameworks through which we control or we express our desire for what kind of society we want. And I think fear-mongering is not the best way to help us take the constructive actions that we do need to take. Because on the one hand, robots and AI are going to cause problems, definitely. But we need those technologies to solve our grand challenges as humanity. We need to fix food. We need to fix health. We need to fix the inequality of wealth distribution. We need to, you know, conserve our planetary resources. There are so many things that I do believe new technologies are the way forward, because we can't. Humanity has never shown any ability to go backwards. You know, push those babies back in, not happening, okay? And in fact, all societies that have tried to limit growth have turned into the worst possible fascist states. So if we're going to go forward with technology, what we need to do is have a deep understanding of where and how those problems will arise and where and how the solutions for those problems arise. There are, I lose count of the number of groups that have suddenly been convened to talk about ethics in robotics and AI, from the World Economic Forum, from the Pope, who has just set up a group,
Future
down
of Life Institute, yeah.
Everybody, and I'm involved in a number of them. So yes, we're concerned, but the group that has had the best broad solutions, this has arisen from workshops around the ethics of robotics and AI in the UK, from the EPSRC group, engineering. We can find the exact link, but on the Robot State site, I have my version of this, simplified a little bit so roboticists or people interested in robotics can understand it a little more easily. And what I love most about their approach has been only 5 guidelines. For example, the CLMA principles number at least 27, and the IEEE guidelines on ethical design frameworks for robotics and AI, it's hundreds and hundreds of pages. And I look at the volume being produced and I think, how is any startup or research lab going to kind of bring in all of that and come up with ideas about what they are and aren't going to do? How does any policymaker understand what they should be pushing for and what they shouldn't? Anyway, with the EPSRC guidelines, what I call the 5 laws of good robot design, we start right up at the top of Maslow's hierarchy of needs, and it's don't build killer robots. Just, there are very few technologies that are single function. Most technologies are multifunction, but the nuclear bomb is one example of a single function technology. You pretty much can't use that for anything else. So there are certain military developments that would be single function robot killing machines, and there is a worldwide call to ban those. We have already conventions on acceptable weaponry, whether it's nuclear or chemical. And in fact, pretty much everyone in the world has signed on to these conventions with regards to robots, the exceptions being Russia and the United States. So that is an obviously good guideline. Don't build killer robots when their sole purpose is to kill. The next guideline is really, don't build robots that break the law. And you think, well, that would seem intuitive, surely, but it's not the case. There are many examples of a robot technology that breaks the law, being built and deployed, and then getting into trouble later on. For example, deploying telepresence technologies in Europe, where there are much tighter privacy guidelines. Here's one of the issues that's starting to come out now: your voice-activated assistants and any robot navigating with camera technologies is going to be breaching privacy as we currently understand it and as our legal frameworks in certain countries define it. So here's the good news, is that some countries have a very strong interest and already a structure to look at privacy and technologies. The US doesn't. So you can get away with a lot of breaches of privacy in this country without it being against the law. But if you think about that, that's a kind of good basic sense guideline to have. Understand what the human laws are and then think about, am I building a technology that is going to be in breach of the law? And then we get down to the middle level, which is like, as we get closer and closer to the individual robot on the technology stack, are you as a company building a reliable product? We have insurance industries, we have product safety guidelines. Now, it's not foolproof. You know, cars are being recalled all the time through issues with poor product, maybe it's just poor component supply or an unexpected interaction between different components. But we have an expectation that if you say your robot is going to do this, that it will do so, and it will do so reliably, and it will do so safely. So that's the third law: build good products. And then it gets a little bit more opaque, a little bit more interesting. It's the idea that the robot is going to do what we say it's going to do. How are we communicating that? And who is going to be building the robots? So the key principle here is don't build deceptive robots. And given that the advertising industry is really bankrolling a heck of a lot of our internet-connected technologies today, they're going to be strongly behind most of our consumer-facing robots in the future. Now, are they going to be clearly telegraphing who is controlling the robot, who has designed the robot, and what that robot's purpose is for? Actually, this is a really great example to hold on, because the final law, for me, is its identification, and it comes down to the individual robot level. Is there an identifier? In all areas where physical goods can be dangerous to us, which is airplanes, sea vehicles, land vehicles, we have a licensing and registration process, and those must be displayed. But look at these robots. Where is their licensing? Where is that information? In this one, we can see a brand name, but this keeps coming up in robotics for me, and I think it's perhaps one of the simplest and yet most significant things that we can do. How are these robots telegraphing to the world around them who owns them and what their purpose is? And if, for example, one of these robots runs over your toddler's toes, what are you going to say? There might, very, very soon in the future, be 4 different robots on these aisles, and 2 of them might be owned by the store doing inventory and shelf restocking, but 2 of them might be owned by other companies. One person is with their disabled friend, or it is a disabled person who is coming through the shop in their robot-powered wheelchair. And another person might have their robot-powered shopping trolley, but it's a third party. It's not a standard shopping trolley. And in fact, we've seen quite a few of these. You can have your own follow me robot cart. You get it out of your car trunk and it follows you around the shops. So 4 different robots, each potentially from different companies, for a starter. How do we say the robot that ran over your child's toes? How do we identify the robot? So I think that this is where we do have to go, just as a standard next. And for me, each of those 5 really simple laws is a way that our policymakers can see the existing policy structure applying to the technology.
The identifier one is so interesting. We have it for cars and boats and planes, and it's time to get it onto all of the robotics that are out and about. And those identifiers will help, like we said, with communication. You called it telegraphing. Yeah,
that's more what we'd use in the interaction studies, but another recent example is the drones that shut down the airport in London. I believe some crash drones were recovered from the perimeters of the airport, but there was no way to understand who owned them. You know, and I'm not saying that bad actors wouldn't avoid that, but you would straight away know whether or not someone was a bad actor. Like, have they taken the license plates off the robot? Oh, that's an indication that it's not behaving well. So we have frameworks in society that technologies properly designed can fit within, so that we can we can produce the best possible behaviors from robots. We can't code that directly into the robot itself. The onus is on us.
Interesting. So the difference between having social fabric frameworks that would help make robotics successful versus the inability to be able to program morality or ethics into them. You can't.
No one's worked out how to program, morality or ethics into people successfully. Many people try, but I wouldn't call it an unmitigated success. And if we look at the limitations of robotics perception and computation right now, both robots and the disembodied artificial intelligences are still incredibly limited. They're very far away from an actual appreciation of place, of context. That's just the giant leap forward, and I believe that that's a very long way away.
And then is there potentially something that we've used with humans that has been maybe one could say like a very successful individual trait or skill that we've developed that has helped a lot with morality and ethics? Like maybe like meditation has been one that's like quite objectively proven to be great for a better ethical and moral behavior. So is there something like that for robots that we could potentially say could be coded in as a skill?
I think when we have more sophisticated behavior from robots, we can look at those. I think meditation's a really interesting one, because what it does is it removes some of the urgency of action. And I do think that humans get in trouble a heck of a lot by taking action on their, what you'd call their kind of systems 1 thinking, not their systems 2 thinking, on their impulsivities and their emotions, rather than on a more considered kind of choice of action. If I was rewriting Facebook, I would put a timer on everything, so that you can't just immediately publish something. You have to sit with it for a day before you can share it, and then it allows you to have changed mood and step back from something, although I'm sure there'd just be ways that people would override that. But I don't think we should allow the instant anonymity, and anonymity is the other thing that allows bad human behavior. And we have seen this with the internet over and over again, and I think this goes back to how people work face to face. We have accepted behavior where you might do something in private that is not accepted in public, but you would be aware of that and you would change your behavior, because social acceptance is a really massive motivator for people. So I think the ways that we can look at coding that into robots, they're so far off appreciating that on any internal level, but by putting identification on robots, we eliminate the ability of them to operate anonymously.
Interesting. We do see that quite a bit with anonymous internet use and some of the propaganda troll bot farms that we've seen that with anonymous actors can kind of create a lot of noise and issues online versus having identifiers towards an actual human or towards a license for a robot in this case could potentially make it so that everyone has a sort of a data fusion happening around their social credit or their social score, and that seems to be one of the ways that we can prevent malevolences. Do you see that as like a robotic social credit as well, of how well a robot is behaving as well?
I definitely think, you know, I'm looking forward to more creative ways that we rethink our online behaviors, and then I think that that might be able to cross to more robotic human interactions. But I think we have to develop a few, you know, really experiment with a few better ways of building our non-face-to-face communications. If you think about it, we've been reducing the human component of our communications really significantly on each improvement forward. And now, as you said, we've got communications that are more noise than signal, and most of the noise is very, very negative. So I think we need to fix that first.
I agree with you. You wouldn't write the horrific comment anonymously if you had to look at the person in the eyes in person. That's a very interesting point. And then last thought around this is, what, you know, you gave us a little taste at this earlier. I'm really curious about your thoughts about it. There's so much propaganda happening in the media about job loss, and I think it's really interesting to ask you to go a little deeper into this. There's a tremendous amount of jobs being created by automation, robotics, artificial intelligence, so many new jobs that are still unheard of, right, for the youth in augmented reality technologies, all the new aspects.
Every job that I see a robot doing is an area that has a huge vacancy. It's tasks that people aren't doing. Otherwise, there's very little commercial incentive. The cost of human labor is incredibly cheap. And as said, humans are incredibly good at things. So a lot of the studies that are all fear and woe about robots and jobs have been quite comprehensively debunked. And a lot of them rest on a very broad definition of robots that is actually computerized automation, which has had some significant impacts. There are entire professions that have shifted. One example, though, for example, is ATMs. And people were worried that the rollout of ATMs was going to reduce the number of local banks and remove the number of bank telling positions. And it's seen the opposite. It's seen an increase in that because it's become cheaper to provide the full services. And what you tend to find is that the mundane service of just getting money out is handled by the ATM, but anything that's a little more tricky is handled by the bank staff. And that's one of the industries that has seen a growth. The other thing is robots. It's taken quite a while to produce the number of robots that we already have. One of the biggest problems we're facing in robotics right now is, can we scale? The market wants robots, but we're having difficulty producing robots, and we're having difficulty staffing robotics companies, and that is just going to get worse because the demand for labor, and it ranges from unskilled to very skilled, is so significant. Over history, human unemployment rate has remained remarkably stagnant, and our labor statistics go back through at least one technological, well, they go back through 3 technological revolutions, including the agricultural revolution, where we went from 60% of the population employed on farms to less than 2%. Okay, that is a huge shift in a job, but unemployment overall remains steady. So we shift jobs. We don't seem to be really cognizant of the idea that we could perhaps eliminate this tight coupling between employment and earnings and start really being creative and saying, well, maybe all humans should have earnings to put back into the economy and make it a really, so there's one whole debate there.
Yes, shifting the shift of jobs is very interesting. I know you've already answered some of our ending questions on simulation. I just want to see if maybe you've had any thoughts on like the updates on if you think we're in a simulation.
I struggle with the idea, like I've looked at the theories, but I still struggle with the idea that a sufficiently advanced simulation would be necessary or desirable. You know, it's like we're building so much bad in the simulation. To me, it kind of defeats the purpose. But, you know, I just focus more on what we're actually doing day to day and seeing what I can do to, you know, make the world a better place. And this is one of the other areas with robotics that we often forget about. There's a strong movement towards looking at the robots that augment humans rather than the robots that replace humans and steal jobs.
For sure. Yeah, the hybrids.
Yeah. Whereas I think, you know, if you looked at that NASA image, we tend to think of the robot as being
Let's pull up the
like
NASA
a
image
mirror.
quick, Ronnie, if we can. Yeah.
Oh.
Yeah. And you look at it as a mirror. Yeah, that's a very interesting one.
That's, you know, absolutely down to our anthropomorphic bias. You know, when we think about robot, we think about it as a reflection of human and as of having all of those same capabilities and issues. And it's that kind of thinking that gets us into trouble. So robots are not reflections of human, except insofar as we can put the surface dressing on. I think it's actually, they're a fascinating mirror back at us where we realize exactly what it is we think humans are about, and where we can reflect on what differences having a different perception system can make.
Correct.
You know, how robots think and perceive is so incredibly different. Okay. What I love about this image is because I always wanted to be an astronaut and discover alien life, and I think this to me is discovering alien life right here on Earth, and it's discovering robots and AI.
Yeah, it is. That's a good way to put it. And then this is potentially us passing the torch to the non-biological intelligence, but also we would like to embed consciousness in the non-biological intelligence, so there can be the feeling of being in the cosmos, exploring and playing and experiencing. Yes.
Well, I think if we look at the studies of other animals,
okay,
we might start to see that consciousness is not simply a human property.
Yes, correct. Yeah, the very panpsychist thought consciousness, infinite consciousness is all that is, absolutely. Last thought is, let's see if you've updated, what do you think is the most beautiful thing in the world?
The view of Earth from space, especially if it means that we're going to space to, I guess, just broaden the base for humanity.
I'm so excited for whatever's coming in Robotics 3.0. I'm very...
I can talk about Robotics 3.0 next time, because we've got some things to say.
Yes. Let's see what is the next the four S's you have now. Let's see what your next array or acronym becomes, because holy cow, the perception systems are getting better. This has been such a cool update on the robot explosion. And Andra, your work is so important and interesting, and we wish you the absolute best, and we wish civilization the best with figuring out how to integrate and hybridize with this. Thanks for coming on again.
Thank you, Alan. It's been a pleasure. And thank you, Ron.
Yes, huge thank you to Ron Vargas, our producer director. We love you very much. Thank you. Thanks everyone for tuning in. We'd love to hear your thoughts in the comments below. Let us know what your thoughts are on the current state of the robotic industries. Also, check out Andra's links below. Go and support Andra. Support us at Simulation as well. All our links are below. Support the artists and entrepreneurs that you believe in. Go and have more conversations with people around you about robotics and automation. And build the future, everyone. Manifest your dreams into the world. We love you very much, and we will see you soon. Peace.